In today's episode, we're joined by a very special guest from the Google Flutter team. Chris Sells is a senior product manager at Google, responsible for many aspects of Flutter, including the end-to-end developer experience, the ecosystem, Flutter Desktop, as well as working with top customers and clients. Chris has many years of experience contributing to the evolution of UI toolkits, including over 9 years as a principal program manager at Microsoft and 2 years as a vice president at Telerik, the makers of popular UI toolkits for the Microsoft ecosystem. Chris has published 12 books over the years on software development using Microsoft component libraries. Links to Chris's publications can be found in the show notes. In my chat with Chris, we cover many topics, including lessons learned from building UI technologies, the evolution of software engineering, new features in Flutter, Flutter Desktop, Flutter Web, and working on open source projects. Chris, welcome to the Dart Developer Show. Thanks for joining us on the podcast.
Very happy to be here.
So, Chris, we have a lot of really interesting topics to cover today. I'd like first to talk a bit about your background. Could you explain what your current role is at Google and a brief summary of your career before joining Google?
Sure. Right now at Google, I am the product manager for Flutter, specifically responsible for the developer experience, our ecosystem work, and working with our top customers and clients. And I also run our desktop work. I'm just one of a team of PMs, but those are my responsibilities. And then before this at Google, I spent 3 years in cloud developer tools. I was a lead PM there in our Google Cloud platform. And then I spent a year doing some tools on the Android platform. I got to be there for the launch of Jetpack. And then I've been in this role for just about 2 years on the Flutter team. And then before I came to Google was a huge shift for me, actually. Before I came to Google, I spent 20 plus years as a contributing member of the Windows developer community. And boy, that work took me all over. I started at Intel, working on the telephony API of all things. Then I did a number of years of training for a company called Develop Mentor. And in there, I started giving conference talks and keynotes around the world and writing dozens of magazine articles and a number of books and doing some independent consulting. I spent 8 years working at Microsoft in a variety of roles. The last thing I did was a couple of years in Visual Studio, and I was there to launch the new programming API that came as part of Windows 8, which eventually became what we now think of as UWP. And then I went to work for a Microsoft partner doing UI components. Telerik was its name before it was acquired. And then let's see. And then after that, I did another little startup. In fact, I sprinkled a couple of startups in there. Some I started myself, some I joined. And then eventually joined Google. That's it in a nutshell, I guess.
Thanks for taking us through that. Having spent so many years in the Microsoft ecosystem, what was it like moving to Google and focusing on a different set of technologies?
Yeah, that was interesting. I mean, when I left the Microsoft world, there weren't really anyone building Windows apps. People were targeting the web. And now there's this big explosion of apps in mobile since then, and Microsoft didn't really participate in that at all. So that was very different and new. And now people don't seem to want to build for just one platform anymore. They want to build a mobile app and target Android and iOS. They want to build the desktop app and target all 3 desktop operating systems, or at least 2 of the 3, right? People seem less and less interested about targeting any specific platform And they seem more and more interested in targeting every platform. So that has been a huge change, right? When I was in the Microsoft ecosystem, we were just adding value for developers building Microsoft, specifically Windows apps, and then Windows Server, right? ASP.NET kinds of apps on the back end. That was our whole world. Now the world has exploded, and people want apps that run everywhere.
Right. Yeah. And that's Flutter definitely ties into that evolution of what users, developers want. I'd like to spend a little bit of time kind of picking your brain, given that you have so much experience building UI technologies, um, working at Microsoft and on Visual Basic and Windows UIs, and now moving on to Flutter. From your experience, what are the difficult things to get right when building toolkits for UI developers, and what are the trade-offs that you often have to make?
Yeah, so it is a constant challenge to build a UI framework because there is this careful balance you have to make between ease of use and approachability, which has to do with tooling in the API, as well as complexity, which has to do with the amount of functionality you try to pack into the UI framework. And then you also need to worry about performance, right? When the thing that you build and you ultimately hand end users, you want it to be as performant as possible. And so you're juggling, how do I make the developer as productive as possible with the development lifecycle and a well factored, well thought out API? At the same time, how do I make sure that the thing that the end user gets, they're not punished because the developer, had a fast, productive time building the app, and then in the middle of all that is, well, gosh, how do I make sure that they have a productive environment, they have native speeds, but they're also able to have control, to make the app look exactly like they want it to look like. Do they want it to look like a generic, out of the box Android or iOS app? Do they want it to look like, their own brand and their look and feel? Do they want it to look like their app that happens to be running on Android and iOS? And you have to let them make those choices, and you have to let them, you know, if you're going to build something that kind of sits on top of all these native platforms, you can't do it at the expense of any one of these things, right? You have to give them pixel for pixel control and animation and high speed scrolling and video playback and all the things that modern apps need while keeping them productive, making a good on ramp, and giving them native speeds. There's a lot of things to juggle to get it right.
Right, I see. That makes a lot of sense. And given that Flutter is in its earlier stage of its life cycle, in what ways does Flutter stand on the shoulders of previous giants in UI development? What would you say some of there's some good things that Flutter borrows from previous frameworks, and in what ways does it avoid some of the missteps?
So some of the things that from an API point of view, some of the things that Flutter borrows from frameworks that came before it was essentially reactive, declarative, and composable. Those three things are the key to what make the API work, in my opinion, for Flutter. So that the idea of declarative comes from HTML, right? I want to lay out, here's what I want. I don't want to draw every individual pixel. I want to tell you, here's where I want, a paragraph and a div and an image and some text. And I want to give you characteristics of those things. And I'll tell you the order, and I'll tell you how to, wrap things and arrange things. But then you do it. Let the rendering engine does it. So that idea of declarative comes straight out of HTML, and Flutter makes a huge use of that, where you can just say, I want a text or an image or whatever, and put them in the order and wrap them in like a column or a row or a stack, and tell the rendering engine how you'd like them to be laid out. But you don't have to draw every individual pixel. You can just let the Flutter framework do that. So that's a huge win from both readability of the code, productivity. It's just a really great abstraction. And then reactive. The idea of reactive is, in the old days when you used to write UI, you'd say, okay, here I'm gonna write some UI. I'm gonna initialize it with some initial data, and then as the data changes, I'm gonna go and update that little piece of my UI that has changed because of the data change. And that is just really, really hard to do well. And so, what Flutter does is it borrows this idea of reactive, and of course, React is a fantastic framework that uses this same model as well as others. The idea of reactive is I want to be able to change my data, and all I have to do is write one method. It's called the build method. And whatever the current state of my widget is, whether it's brand new and there's some initial state, or whether the state has changed, or whatever it is, you just implement one method, the build method, against the current state of your widget. And that makes it super easy because there's just one code path. You just have to draw things, or you have to lay out all your widgets based on what the current state is. And then what Flutter does is it takes the current state of your UI and it looks at whenever the underlying data changes, it goes and it looks at your new state because it just called the build method. And it compares the two. And it only applies the diffs. So you don't have to worry about that. The underlying Flutter framework is applying the diffs for you. All you have to do is, when your data changes, you notify Flutter, it will call your build method, you draw whatever the thing is for the current state, and Flutter will just magically handle the diffs. And then the third thing is composability. This is something that is relatively new. We've had this before in other frameworks, but traditional UI frameworks do things like, hey, if I want a new button, I derive from a button class. Or if I want, a text editor with different functionality, I derive from the base text field and I go to town. Flutter uses composability. So when you implement your, my widget and you implement your build method, what you do is you nest all of the other widgets that you want your build method to have in it, and you compose your larger Flutter widget with these smaller pieces that come out of the box with the UI. And then you can build on top of that to make it bigger and bigger things. And by the time you're done, you've got a whole app. And in fact, an app is just the top level widget, and it's just all widgets all the way down. And so those three principles, we've seen them all in frameworks before, but Flutter kind of, because it was able to start with a clean slate, a whole brand new API, was able to bring those together so that they all blend so well together. And the finished code you get is so small and so clean and so nice that, in fact, we're seeing other frameworks start to borrow some of those principles that Flutter had. I'd like to think that Swift UI and Jetpack Compose were influenced positively by the design of Flutter.
That's fantastic. Thanks for taking us through that explanation. I'd like to talk now a little bit about Flutter's place in the evolution of software engineering as a whole. When I first came across Flutter, it struck me as simply not another front-end technology. It feels like it could lay the foundation for a new wave of software engineering, in the same way that you have these big transitions moving from assembly to C and then to high-level languages. Having to rewrite code to work on different platforms creates a lot of friction, and removing that generates a lot of economic benefit for society as a whole. It opens up doors to more developers. It frees them to spend more time working on solving problems for end users. Is this kind of taking it too far, or do you think Flutter could in some way, and also Dart by extension, become a bedrock for the industry as a whole in that way?
Well, certainly, I'm not a biased observer here, right? I mean, it's my job to help make sure what you just said comes true, and I hope it will. I mean, I moved to the Flutter team because of how much I love Flutter, right? I saw Flutter and I saw an opportunity to move to that team, and I'm like, this is fantastic. I can't wait to come work on Flutter. And the more I learn about Flutter, the more fantastic Flutter is. Honestly, it's amazing. A lot of times you scratch the surface of some API or some framework or some library, and it gets pretty grungy pretty fast. But the deeper I dig into the Flutter, the more I like it. And again, I'm biased, right? But the interesting thing about where Flutter is in the industry, as you talk about, this idea of a foundation for the future. I mean, you can think of a whole new class of developers that are Flutter developers, people that pick up and start writing Flutter code, and then they think, oh, they can worry about where they're going to target it later, right? Oh, I want it on Android. Oh, I want it on Windows. Oh, I want it on the web, right? The idea is that they can be flexible in terms of where they want to target their app, which means that all these platforms that allow Flutter to run, or rather, that Flutter supports, become you can just see all these things expand to enable Flutter. And there's two things that enable that. One is this ability to, every time we add a new platform to Flutter, we extend the reach of Flutter and we lower the risk of somebody picking Flutter up, right? Because it's less about I want it to be on the web, I want it to be a desktop, I want it to be on mobile, and more about the Flutter skills themselves, and you can target it at these various things over time. But that's only one piece. That wouldn't work if Flutter was a least common denominator. There have been other cross-platform UI frameworks in the past. Write once, run anywhere, was the tagline for these kinds of things that have failed because they took the least common denominator approach, right? Let's make whatever everyone does, let's make that the way we do things. And that doesn't work because each one of these platforms has idioms that are specific to that platform that you want your Flutter app to adopt to. Maybe it's the way you input, maybe it's the way you navigate, maybe it's the form factor, the way you do output, right? All of these things can be platform specific, and you want Flutter to take advantage of those things so that they blend in, right? So it feels like a Windows app when it runs on Windows, and it feels like a web app when it runs on web. That's important because it doesn't matter to the user that this app runs across multiple platforms. To the user, they only care that it runs great on the platform that they're running on. So you have to adopt and adapt these idioms. The other thing too is every platform, and this is always going to be true, every platform has unique abilities. Every platform has things that it does better, differently, in a way that no other platform does. That's how they differentiate the platforms themselves, and they will always be doing that. With that being the case, you need Flutter to be able to get to the native versions of the APIs running on any of those platforms. If you're running on Android, you need to be able to have full, complete access to the Android API. If you're running on web, you need to be able to get to all the browser APIs and all the JavaScript libraries that you might want to plug in. And the way we do that is that there is always a native component of every one of your Flutter apps. Even if you don't write any native code at all, it's there. It hosts your Flutter code. It runs as a shell for your Flutter app on every one of these platforms. But the beauty of that is because that layer is always there, you can always go to that layer and write whatever native code you want to for whatever platform you're targeting. You can always communicate between your Flutter code and that native code. So this idea of being able to hit every platform only works if you can be great on all the platforms that you're targeting. And Flutter works really hard to make that a possibility for our developers.
That makes a lot of sense. And I think that's a good segue into our next topic, which is the latest release of Flutter 1.22. I understand this has been one of the biggest releases to date, and it brings with it a lot of those same compatibility features that you were talking about that need to be there for all the platforms. So it brings with it a lot of the new features in iOS and a lot of the new features in Android. I'd like to dive deep into the one particular feature, which I think the listeners might need help wrapping their heads around. And this is Navigator 2.0. Could you talk a bit about Navigator 1.0 versus 2.0 and the use cases that it supports?
Yeah, it turns out that kind of the underlying concept of a navigator is the same almost no matter what toolkit you're running, even if it's web or whatever. But the idea of a navigator in general is it's going to manage a stack for you, right? It's going to manage a stack of screens, right? And so you're on the home screen and you press a button and you navigate to another screen. Boom, you're on screen number 2. And you can imagine there's a stack because when the user goes back to, from page number 2 to page number 1, they want to see all the stuff on page number 1 that they saw when they were there before, right? In the mind of the user, right? There's this mental stack. And that's the case for the developer too. When we were using Navigator 1 in previous versions of Flutter, or still today, you can still use it. There was still that stack, but it was invisible to you. Just like it's invisible, it's just in the head of the user, right? But it was invisible to the developer. And for certain advanced scenarios, that was really hard to deal with, right? For example, you're on the web and you've got a multiple nested deep link and you want to get to the 6th page. Well, you want to build a stack of all 6 pages so that when they go back, they're going to find all the pages that they skipped past, but are still there in their mental model, right? Or, you want to get to a certain page and then on that page, you want to do some nested navigation where you want to, from there, you want to nest into different places, maybe on the same screen. And, there's some complicated scenarios. And all of these scenarios were really hard because you couldn't see or directly manipulate that stack of screens. And it just made it hard for a developer. And that's so all you could do is say, you could say, oh, navigator.push, here's a new screen, navigator.push, here's a new screen. Then you could say .pop, then you could say .pop until, oh, I want to go all the way back to this page in the stack, or I want to, go all the way to the home page or whatever. And there was all these kind of indirect ways for you to manage the stack. But there was no way for you to just say, forget all that other stuff, here's the stack. Based on the current state of the app, it's this page on the bottom, and then this page, and then this page, and then this is the page the user is looking at, right? There was just no way to do that. And that's what Navigator 2 allows. With Navigator 2, you can actually create your own Navigator, and you can say, here's a set of pages. And those pages can, just like your widgets, update over time in a declarative way based on the state, and the state changes. You can do the exact same thing with Navigator 2. You can say, oh, hey, that stack, based on I'm logged in. There's only one page available, or I'm not logged in. There's only one page available. Log in. They can't go anywhere else. They can't do anything else. They're not logged in. Boom, they have to go to the login page. Great. Oh, they are logged in. Well, there's no login page in the stack at all. They don't need to log in. They've already logged in. And, things like that are now super, super easy. Or, the browser hands you a big, long string for, a URL, and you want to compose a path. That allows you to say, oh, okay, now the stack looks like this first, then this, then this, then this, and this is where they are. And you are allowed in your program to lay out the elements of the stack just like they were widgets in your build method. It's first this one, then this one, then this one, and then this one. And it gives you that declarative model on top of the navigation, whereas before it was imperative. And it was hard to deal with, and it was hard to manage, and it was hard to control. Now, the navigation stuff I laid out, and there's a fantastic blog post John Ryan wrote all about navigation too, and routing, and all the powerful things you can do. We're not quite done yet. Some of the scenarios, like the initial URL from the browser, we're still integrating. The intent from Android, and getting that into your app and navigating to the right place. We're still integrating some of those pieces, but already today, even without those pieces, it is such a pleasure to be able to visualize directly that navigation stack. That now that I've done it, I don't want to do it any other way.
Thanks for taking us through that. I can definitely see how that comes in handy. I had a brief look at John's blog post where he was talking about the browser scenarios and the how you have the different parts of the path. So I can definitely see how that helps to kind of mirror what users and developers would have in their mind, being able to model that precisely. And how does that relate to state restoration?
So whether you're using Navigator 1 or Navigator 2, as I say, it's just a different API for managing the underlying stack. Now, part of that's, well, okay, so that's this. There's the stack, right? The navigation stack. Now, I'll put that on the stack, and I'll pop it in a minute. The state restoration. The idea of state restoration is, hey, sometimes when you're running on Android or iOS, your device, which doesn't have nearly as much memory as a laptop or a computer or whatever, your phone is going to experience some memory pressure, run out of memory, whatever, and the operating system is going to go through the list of running apps and go, hey, none of these are in the foreground. I'm just going to kill them to reclaim memory so that the user has a good experience for the app they're actually running. And then when the user goes back to that app, maybe they use the back button, or they get a list of the apps and they pick it from that list. When they go back to that app, it's going to pop up the app again. Now, what the operating systems do is they allow you to give it, when they're about to be terminated, they give you an option to say, hey, would you like to save all your state in a persistent store that we'll give you? And then right before we kill you, we're going to reclaim all that memory. But then when the user switches back to you to give them a seamless experience, we're going to pretend like you were here the whole time. So what we're going to do is wake you up, hand you back that data, and let you restore your state to where you were right when the user was using you. And that's, where you are in the navigation hierarchy and what data is on all the screens in the navigation hierarchy. And, even down to they were, 3/4 down on their scroll, right? All of that stuff we want to save. Now, we showed a preview of state restoration that supports Android, and it does all that stuff. It hooks up to the events, and you can, decorate your data, and it'll automatically be restored for you. But we haven't done everything. We haven't made it so you can restore everything just yet. That's why it's a preview. And another reason it's a preview is it runs on Android today. We haven't yet done the iOS implementation. But one of the big pieces we left out with state restoration in its preview form is the navigation itself, that stack, that navigation stack. And the reason that's important is without saving and then restoring the navigation stack, your users aren't going to end up on the same place in your app, if that makes sense.
Yeah, that definitely makes sense.
Yeah. So that's how they relate, right? The navigation stack is one of the things you want to save and restore. Some state you want to save and restore, and we're not there yet. Now, that's coming in future betas of Flutter, and of course, it'll be there in the next release of Flutter, but it's not there yet, which is why state restoration is still in preview.
I see. I'd like now to move on to talking about Flutter Desktop. Recently, I saw that Flutter for Windows reached an important milestone. It's now in alpha. Could you talk a bit about the journey to get to this milestone?
Yes. So Windows obviously is a big deal, right? Whenever we talk about Flutter for Desktop, every group of people I ask, every group of developers I ask, what's your number one operating system you'd like us to target first? And their answer is always overwhelmingly Windows, right? We want Windows first. And of course, that makes sense, right? Windows is the dominating platform. It's more than 50% of where Flutter or Flutter developers run their developer tools is on Windows, right? Windows obviously very popular, especially in the enterprise and even consumer. They're just very popular. And if you're going to write a desktop app, no matter what framework you're in, if you're going to do that, the first operating system you care about is Windows. Great. So why, if that's the case, why did we ship that one last instead of first? Well, Mac OS, right, is very near and dear to the hearts of Google developers. And so we just had more Mac OS expertise on the team. That one came out first. Also, we had some internal partners who were doing developer tools for designers. And in that particular case, Mac OS comes first, right? That's one of the rare cases where you do Mac first before Windows. Most of the designers live in the Mac. Great. How did Linux happen second then? Well, of course, We also have a lot of love for Linux internally. However, the reason we did Linux next was because we partnered with Canonical. And in fact, they're the ones who built the lion's share of the Linux implementation of Flutter, and they're the ones who are pushing it forward. And they've been driving kind of awareness events and working with existing Flutter developers to get a lot of Flutter apps into the Snap Store and making it super easy to not only build a Flutter app on Linux, but to actually publish it into their store. They've been doing a lot of work, and they're driving the implementation forward. We're in close coordination with them, but we're driving the implementation forward. The Windows side was harder because there is an API. If you're doing native work with Windows, if you're building a plugin that supports Windows, which is a plugin is a combination of Dart and Flutter code and native code that targets one or more platforms. If you're doing that with Windows, there's an API you have to use. And that API is whatever the native API is for the platform. So on Android, it's Java or Kotlin. On iOS, it's Objective-C or Swift. And on Windows, it's C++. However, there's not one flavor of the Windows APIs. There's two. There's the Win32 API, which is terribly named, but it's the one that sticks with it. And it's all the C-based APIs that we've had with Windows forever. And you write C code or more modern C++, and you can get to the underlying API. Then there's the new one. I mentioned UWP. UWP is a much more secure kind of Windows app that runs in a sandbox that doesn't have full control. It's safe to install. You don't need admin access because it's running in a sandbox. It's the future of the Windows API, but it's not here yet. It's for, you can take a UWP and you can run it on a Windows 10 or a Windows 7 box. You can run it on an Xbox. You can run it on a HoloLens. UWP is, kind of next generation of Windows API. So that being the case, we didn't want to only do Win32 because we didn't want to lock people into only existing, a billion Windows devices isn't a small number, obviously. But even so, the future devices are going to do a lot of UWP, and we didn't want to block those folks out. So we had to spend a lot of time, even though we don't yet support UWP, we just spent a lot of time doing design work and understanding UWP so that we could have an API that would serve for both Win32 and UWP. For example, you couldn't pass around HWinds, which is a Win32 concept that doesn't have any mapping in UWP. So we had to come up with an API that allowed us to be flexible for the present and the future. And that was a lot of hard work. And that was the big sticking point. Once we figured out what that API was and how we could support Win32 today and UWP in the future without a big disruption, then we could, make sure the redrawing worked well, and we could, make sure that we were mapping the keystrokes and handling Xbox controllers and, doing the right thing with the mouse and the touchpad and the mouse wheel and all of that stuff, that you have to hook up to make Windows really work. And the plugins, we implemented a few plugins and, all those things. That was relatively easy work. It was real engineering and we had to do it, but we had to first unblock ourselves on a design that worked for both of those versions of Windows. So that was the big journey when it came to getting Windows out the door.
I see. So now you're building off a really solid foundation. What's left to get it to beta and to a full 1.0 release?
Yeah, so we have, for all three operating systems, we have the shortest list possible. We have to make sure accessibility works, or that's on our big wish list. We want accessibility to work, and even if we do, that one's a big one. That is actually our biggest, hardest one. If we don't make that work in beta, for sure we'll make it work in our stable release. But that's one we really want to get done in beta. We also, as people use desktop apps more, They do larger bits of text entry, multi-line text windows, which are not a big deal for mobile. And we have a great story when it comes to single line text. When it comes to multi-line text and all the keyboard mappings that you just have at your fingertips, or how the mouse is supposed to work, and all of those things. You want that to just work. It doesn't have to be amazing. It doesn't have to be a programming text editor, but it just has to have the basics in it, so that people will sit down and do multi-line text editing on a Mac or Windows or Linux, and will feel natural to them. So that's some work we want to do. More we want to do. We are unlikely to get multi-window support, multi-top level window support in desktop, but we want to make sure when people do things like context menus, that the all the accessibility all the content in a content menu is accessible without hitting the edge of the window and being cut off, and now you can't get to the rest of your context menu because we don't support multi-line or multi top level windows. Internationalization, localization should be largely done, but we want to double check and make sure that we're done a good job there. We've got some font handling we want to get in. Oh, command line arguments. It is very common for desktop, right? You integrate with the shell during a setup, double click on a file of your specific type, and boom, it opens your app. The way the shell communicates that to you is on the command line. And today, you can handle the command line arguments if you're writing pure Dart, but they aren't reflected in your Flutter app. There's a main, and there's a string or a list of strings that are called args, but it will always be empty. So we have to fix that. Make sure that you can integrate with the underlying shell via the command line. Trying to think, there are some other things too. One particular, just a pet peeve of mine, I'm hoping we'll get to, we'll see, is the reorderable reorderable list view, which is this idea of, hey, we'll provide you a list of things, and then you can grab any one of those things and drag it around the screen, and Flutter will just handle all that for you, all the rearranging, and it'll just move the items, which is super handy if you're on mobile, especially Android. Android users are used to like long press, and then they move things, and that's how it's activated, with the long press. But nobody in the PC, and that, by the way, that works with a mouse, but nobody in the PC world would ever think to long click with something on an item with a mouse before they can drag and drop. It just doesn't work. They're used to drag handles. They want to click on a drag handle and move it around. So we have some work to do there to make things like that work. But that's it. I mean, it's not a lot, actually, for beta. The other big thing, of course, we want to do is get, as more and more people are building desktop apps with Flutter, we want their feedback so that we can fix these crucial issues that people run into, crashes with this version of the operating system or that device driver, or, et cetera. Those are the kind of critical things. We don't have all the hardware. We certainly do not have every possible version of Windows on every possible combination of graphics cards. So we really need help there. People trying out their Flutter apps and giving us feedback in terms of how it works. So that's also a big part of beta. How many of those critical issues can we fix?
That's great. It sounds like there's some exciting things coming down the pipeline. Before we move off the Flutter Desktop topic, I have one last question, and this is related to Linux and the work that you're doing with Canonical. Given that Linux powers a lot of IoT devices, industrial machinery, smart appliances, signage, things like that, given the vision for Flutter to be on all surfaces, I would imagine that Linux support for Flutter could open the door to many more surfaces where Flutter could power the UI. Is this part of the bigger vision for the collaboration with Canonical, or is it mainly focused on the desktop for now?
Yeah, that is a good question. The Flutter team right now is supporting 6 platforms, and that's plenty. That said, our overall goal, you talked about a new foundation for building apps with Flutter and Dart. The overall vision for Flutter is really to enable this idea of ambient computing, right? No matter where you have a surface that provides pixels, ultimately we want Flutter there, right? Flutter at its core is an engine that does the translation between these drawing instructions and whatever the underlying GPU is using Skia, and it does text layout, and there's a little Dart runtime, and on top of that engine we build all the widgets and all of that. So the Flutter engine plus the Flutter framework is a relatively small package that we would like to see run on everything, Arduinos and Raspberry Pis and this long tail of devices that we can never support directly. But we would love the community to kind of adopt Flutter and make it work on all those things. And we have had companies reach out to us to make Flutter run on all kinds of crazy things. And so sometimes, it's a Linux-based something. And so, Canonical is great. They have expertise, of course, in embedded Linux. And now that they have expertise in Flutter too, we try to make those connections when they make sense. But even Linux is only one part of where we'd like to see Flutter get to over time.
Okay, that makes sense. I'd like to spend a few minutes talking about Flutter Web. I see it's also made some big strides over the past few months. The web, to me, seems like a different challenge compared to native mobile and native desktop, in that on these native platforms that you're targeting, you have full control over the pixels, whereas on the web, Flutter UI needs to translate into HTML and CSS, and that translation might not be perfect all the time. Can you talk a bit about some of the challenges of Flutter Web and how the team is approaching these?
Yeah, so we really have actually, you can think of it really as two backends for Flutter Web. One is, as you say, right, translating to the HTML DOM and CSS styles. And it's an imperfect mapping, as you might imagine. Ironically, the Flutter team itself started by kind of taking the HTML rendering engine and cutting out all the legacy and seeing how fast they could get. And they built this very fast, order of magnitude faster, because you don't have to worry about the legacy. And of course, now it becomes worthless for the web. So that's what turned into the core engine for Flutter, and here we are today. And that team, a lot of the initial Flutter team came from the Chrome team. So there's a lot of influences on the Flutter team from HTML. So you might even think that web is our first love, but you're totally right that there isn't a one-to-one mapping, right? When the Flutter team had the ability to kind of start over with a clean slate, right, they could make the theming as part of the API, unlike CSS and HTML, where all those things and JavaScript, they all kind of evolved independently of each other. So there's two backends, one that targets the HTML DOM that doesn't map 100%, and then there's another backend based on something called CanvasKit. And I think I mentioned that kind of the bottom end of the Flutter engine is something called Skia. And Skia is kind of the C library that we use across all these platforms that essentially maps Flutter rendering to whatever the native GPU is on that platform. That's how we achieve platform independence when it comes to high-speed graphics output. And it turns out that the web has a Skia engine too. It's called CanvasKit. And the idea of CanvasKit is it is a Skia implementation that is built on top of Canvas. And as you may or may not know, Canvas is essentially, a pixels-based API where you can draw shapes and pixels and lines and blah, blah, blah. And you essentially have full control inside of a canvas. So that nice thing about that full control is we can do the mapping at a very high fidelity between Flutter and CanvasKit because we already do that, right? I mean, eventually Flutter always boils down to Skia calls. Flutter for web, if it boils down to Skia for web calls, then we have we can provide an amazing experience for folks and a much higher fidelity, and as it turns out, much higher performance. So We're experimenting with Canvas Kit now. We're pretty happy with where we're getting. We're not done yet by any means, but that is an exploration for us right now to get to that much higher fidelity that you're talking about.
I see. That's very insightful. Thanks for explaining that. Are there particular use cases that where you've seen Flutter Web working particularly well today?
Yeah. We very much think about Flutter Web. We think about Flutter as apps, right? Are you building an app? Are you building an experience where the user interacts with something and does something, whether it's a enterprise app, whether it's a utility, whether you're digging through the Google Maps, whatever kind of app you're building with beautiful visuals and native scrolling and animation and all of that stuff, complete control over every pixel on the screen. We think of Flutter for building apps, and of course you can target those apps at mobile or desktop or web. So an app. I would not say that Flutter Web is optimized for scrolling through content, right? So, you go to a blog on the web, and that's a bunch of scrolling content, right? Pages and pages of scrolling content. That is not something that Flutter optimizes for today. It works really well for apps. It's got built-in support for progressive web apps. So it comes out of the box with the metadata. So in your browser, whether it's a mobile browser or your desktop browser, you can actually click a button and kind of install the Flutter Web app on your device. It gets its own icon, and you click on it, and the address bar goes away, and it just looks like a standalone app, like any other desktop or mobile app. But it happens to be driven by the web engine. So those are the kinds of apps that Flutter Web is currently optimized for.
So thanks for taking us through that. I'd like now to talk about Flutter as an open source project. Given the global nature of Flutter, and you got people all over the world using it and contributing to it, in addition to the people who work for Google, what's it like to coordinate all that work of individual contributors along with people that work at Google and industry partners? How do you make all that work as an open source project?
Yeah, that's hard. There's a lot of moving pieces. When you're dealing with, I think we're in the top 10 right now of starred, software projects on GitHub. That makes it super popular. We get thousands of issue reports and pull requests every month. I mean, it takes a lot to keep up on all that. Plus, the team itself uses GitHub, as a way to say, here's our designs. Here's a project, and then here's a bunch of sub issues that represent individual items of work. I mean, we use that issue database for pretty much everything. So it ends up with a lot of stuff in it, and we have to manage all that stuff. And so we have a series. So we have help. Nevercode, the company that does Code Magic, which is a CI/CD tool for Flutter. They also help us with incoming triage. So all the initial issues that come in, we first ask, hey, what's the reproduction case? Can we reproduce this and see it before we pass it on to the eng team? And then it passes through a series of filters to set tags in terms of severity, right? Is it a regression? Is it a crash? Is it something that one of our top partners considers crucial for them to ship their apps? So there's all these tags and filters. And based on the tags and filters and what area it is, the individual engineering team then goes and triages and say, okay, which of these can we do? Which of these do we need to fix? Which can we leave for later? And then the most critical ones is kind of the leads of all of Flutter. And we get together in fact, we're getting together right now in 8 minutes to go through and say, okay, of all the most critical issues, where are we? Do we have an engineer assigned to them? What's their ETA? How are we making any progress? Are they blocked on anything that we can handle for them? And all of this is all documented on the Flutter Wiki. The contributors, of course, are not just Google employees that provide these issues, and of course the pull requests, which go through a similar process for us to grade and accept. For example, are there tests associated with a pull request? If not, we send it back. Things like that. Do they pass all of our pre-commit tests? When we merge those? Do they meet our coding guidelines? All of this is all documented in the Flutter Wiki, and it's really Ian Hickson who is driving all of this on our project to make sure that we have a very high standard for pull requests, what information needs to be an issue, how do we get these resolved. He's really leading all of this, and is a monumental task. And it's him, and then most of the rest of the team participates in all of this in one way or another. It really takes all of us to manage the open source project itself, as well as, of course, we're contributing code ourselves, right? We contribute code just like the rest of the community does. It's no different for us. We have the same set of standards. We do the same set of stuff for us as well as the rest of the community.
Yeah, and I think what you described was a great example of how the open source community really pulls together to make things happen. So I know you've only got a few minutes left. The last topic is talking about your writing. So I Googled and did the search on Amazon, and you've written 12 books in your career. That's very impressive. How did you manage to write so many books?
Yeah, that's an excellent question. I think there might have been some mental health issues involved. It is super hard to write a book. If you care about the level of quality and people being able to pick it up and understand it, in fact, it is so hard to write a book. I would say that if there is anything else you'd rather be doing than writing a book, that's what you should do. Because even when you think you're done, you're not done. When you think you're done, then you have 20 reviewers hammering on you about how terrible it is, and then you have to go through and fix all those things or do whatever you want to do, and then you have to go through the copy editor and fight for the idiomatic phrases that are represent your voice, or roll your eyes and go, no, you're right, the 17th great in 2 pages is probably not the right word, or it's just there's so much to writing a book. And then once you're done, there's so many books in the market and so many free resources and online training, so many other things competing with your attention. I mean, when Charles Petzold wrote Programming Windows 3.1, he had so many sales, he actually broke the Microsoft Publishing accounting system. They were paying everyone on a quarterly basis, but the numbers that they had in their system didn't go high enough to track all the sales. So they had to pay him on a monthly basis, right? Those are the heydays of books. Now, gosh, if you sell 10,000 books, 20,000 books, you're doing so great. And that's still pretty rare. So it is just really, really hard. And so you asked me how I did that through 12 of them. And I'll tell you that the only reason I could get through it is because I couldn't not. I had a story to tell. The book format turned out to be a great format for me. I was as surprised as anyone. And these were just things that I couldn't not write down, if that makes sense.
Yeah, no, that does make sense. So given that you are a book writer, do you see a book about Flutter or Dart in your future?
So I swore that I would never write another one after the final one. But I have not been able to help myself from outlining a Flutter book, which would be a completely different book than the books on Flutter and Dart that we have today. In fact, there is a brand new one out, the Flutter Complete Reference by, for example, Felix Angelov and Remy Rousselet. I mean, these are luminaries in the Flutter community, And they have provided this giant book in terms of how to program in Flutter. In fact, the first 200 pages are Dart, how to program in Dart, before they even talk about Flutter at all. And it's as up to date as it could possibly be. In fact, they already talk about null safety, and we haven't even really, shipped the final production version of null safety yet. So they're right on the cutting edge, and their book is fantastic. So that's the book I would recommend if you're getting up to speed on Flutter and you're trying to make the most of Flutter. The book I would write would be very different. It would start from first principles and build up, why Flutter is the way it is. And yeah, it would be very different. But on the other hand, even though I swore I'd never write one, and I just gave you the name of a fantastic Dart and Flutter book, I still can't help myself from thinking about what that book would look like if I did write it. So what did I tell you? I said it was mental illness. So there you go.
Right, but I think we all benefit from your writing. So I look forward to that book if and when it reaches print. So I think we're out of time. Thanks, Chris, for taking the time to talk through all of these topics. It's been really fascinating and educational. And thanks again for everything. Do you have any final thoughts for the developer community?
Yes, here's my final thought. If you're on the fence about Flutter, just try it. Doesn't matter if you're a web dev or a desktop dev or a mobile dev, spend a weekend and build something. I have rarely met the developer that once they've actually been able to use Flutter and get their head around it and build something, and then they see how easy and fun it is. Fun. Flutter makes programming fun again. Once they see how easy and fun Flutter is, I dare you to give it up again after that.
And that's an excellent way to end the podcast. Again, thank you, Chris, and look forward to hearing more exciting things from Flutter in the future.
Great. Thanks very much for having me.